So we have seen that the data got split into three subsets based on the feature outlook, because that feature is the one which gave us the maximum information gain or maximum entropy reduction. And the three subsets are where the data belongs to outlook sunny and outlook overcast and outlook rainy. And for this particular data, the entropy on this data at this level of data is 0.971, which means that is the level of uncertainty which is very high. At for this particular subset, the entropy is 0, which means uncertainty is 0. And then again over here, the entropy is 0.971, same as this one. So at this place, at this subset, the entropy is very high, that is uncertainty is very high. So decision tree will again divide this data, that is split this data into further subsets, either based on temperature feature or wind or humidity, based on whichever feature will give the maximum reduction in entropy or the maximum reduction in uncertainty. So again the same formula would be used to compute the entropy before, that is before splitting. This is what the data set was, this is what the subset data was before splitting. After splitting, let's say based on temperature, I might have two subset that belongs to temperature high and subset that belongs to temperature normal. And now the entropy at this level and at this level will be calculated, and then the weighted average of that entropy will be calculated, and you will get a certain entropy level. That entropy and this entropy will be compared and seen how much is the reduction in entropy or reduction in uncertainty. So that is done using the same process again. So this will be considered as the data set now. At this point, I have entropy as 0.97 because I get, there are two records that belong to yes, and totally there are 5 records. So 2 by 5 log 2 by 5 minus 3 by 5 because 3 no, 3 records belong to class no, minus 3 by 5 into log 3 by 5 to the base 2. So the entropy at this data is 0.97. Now I can divide this data, or I can split the data either based on temperature or humidity or windy. Let's say what happens if I split the data based on temperature. So if I split the data based on temperature, I have 3 options, that is I get 3 subsets. When the temperature is hot and mild and cold. So when it is cold, I have only one record, and that record belongs to yes, class yes. So in that case, straight away, as per the formula, the entropy is 0. And in case of mild, I have 1 and 2 records, one belong to yes and one belong to no. So 1 by 2 for probability of yes and 1 by 2 for probability of no. So overall the entropy is 1, uncertainty is 1. And for temperature hot, I have 2 records, both the records belong to class no. So minus 2 by 2 into log 2 by 2 minus 0. So I get 0 as my entropy. So when I take the weighted average of all these 3 subsets, I get the entropy at the temperature level, that is at the temperature split level, which is 0.4. So the information gain that I get after splitting the data based on temperature is 0.97 minus 0.4, that is 0.57, which is a good information gain. Now let us say what if I split the data based on humidity feature, and humidity has 2 categories which are high and normal. So I will get 2 subsets. One subset belongs to normal and one subset belongs to humidity and high and normal. Alright, so over here, as per the formula, and you apply the values, you will get the information gain you will get is 0.97. That's because whenever the values are high, all the records that belong to high, all of them are no. And for all the records that belong to normal, all of the records belong to yes, which means there is 100% accuracy, isn't it? Because all the records under this subset have yes, and all the records under this subset have no. So when I apply the formula, I'll get minus 3 by 3 log 3 minus 0 and minus 2 by 2 log 2 minus 0, and then the weighted average. So I end up getting entropy at the humidity level as 0. The uncertainty is 0 because accuracy is 100% there. That's why the information gain is this minus 0, which is 0.97, which is the highest information gain possible at this point. Similarly, if I split the data based on wind, I would end up getting information gain as this much. So based on all these three features, all these three possibilities, humidity is the feature that is giving me the highest entropy reduction. So the next split will be humidity. That is, the decision tree will look like this. Initially, I had a data with 14 records and the class distribution was 9:5. That got divided into three subsets, where the first subset belongs to sunny, outlook as sunny. And next I would have overcast and rainy. Over here I had 4 rows. All the 4 records were belonging to category yes. So 4 is to 0, yes is to no, this is yes is to no, and I had 5 records here and 5 records here. And the entropy at this level was 0.94. At this level it is 0.971. At this level it is 0, and entropy at this level is 0.971. Since the entropy is high at this level, the decision tree will again decide to further split this, and it is splitting now based on humidity, because humidity is the one which is giving the maximum reduction in uncertainty. Humidity. The values for humidity are high and normal. And I have 3 rows here and 2 rows here, 2, and so here I get entropy as 0, and here also I get entropy as 0, and so entropy at the humidity level is also 0. This is the entropy. Entropy at the outlook level, as per this, it is 0.693. 936. All right, so this is how it is. And now if you have observed over here, the data, initially I had data which had 14 records, and that got divided into 3 subsets, and again this got divided into 2 subsets. So the number of records inside each of the, after each split, the number of records inside each of the subset is getting decreasing, right? Because that's obvious, because initially you had 14 records, and when you divided, you have some records here, some here, and some here, and then again you divide this further, so some records will go here and some will go here, and so on. So as the depth of the tree increases, the number of records will keep on reducing under each subset, right? And you can call this as a leaf node, because this cannot be split further. This cannot be split further because anyway I am getting 100% accuracy here, isn't it? I am getting 100% accuracy here. So there is no point in splitting this again further based on anything. You can split it based on, let's say, temperature or whatever, but there is no need to do that, because anyway the accuracy is 100%. So the decision tree will not split this subset any further, and this will be called as leaf node, because this is not, this is the last node. It cannot be split any further. This is called as leaf node, and this is also called as leaf node. Similarly, this is also leaf node, because over here again there is no need to divide this data further, no need to split this data further, because I'm getting 100% accuracy. All the 4 records belong to yes. But this one has to be split further, and it can be split because the entropy is high for this particular subset. It is 0.971. Entropy is high, uncertainty is high. So again, the split can happen again based on either humidity or temperature or the other feature, which is wind. So again, the entire process will be repeated, the formulas will be applied, and the entropy reduction will be calculated, and then an appropriate split might be chosen. So I will end up getting a certain subset like this, and maybe again the decision tree will try to divide this again further based on some criteria. So this process will happen until the nodes cannot be split any further. Nodes cannot be split any further, right? That is, whenever the accuracy is the highest, that is when decision tree model will stop. Decision tree model will stop. Until then, the decision tree model will keep on splitting the data into subsets in the pursuit of increasing the accuracy, or in the pursuit of decreasing the root mean square error if it's a regression task. All right. So decision tree will keep on dividing the data into subsets like this, 1, 2, 3, and then again this got divided like this again, and now there is no need to divide this any further, because anyway at this level all the 3 records are having 100% accuracy, because all of them belong to category no. And at this level again no need to split any further, because again here I'm getting entropy 0, which is accuracy 100%. But at this level I need to divide, the decision tree will divide the data further, split that data further, because the entropy at this level is high. And this will keep on happening until there is no need to split the data any further in the pursuit of increasing the accuracy. Okay, so this is in short how decision tree model will construct a particular decision tree based on the class distributions of the data that we have. And this is a simple example with 14 records, but in general we will have millions of records, and there could be multiple classes, not just a binary class, yes or no, it could be multiple class. And there is also one more formula called Gini index. Gini index, instead of entropy, which is P log P before and after, I could also use another formula called Gini index.